Hey, it's Tony from Adafruit, and in this video I wanted to look at examples of the Hypertext Transfer Protocol with the ESP8266 MicroPython. So there are actually some cool examples in ESP8266 MicroPython that show you how to use HTTP, which is what all of the web pages that you access, that's the protocol that they use to send and receive web pages. So you can actually make your ESP8266 MicroPython board look like a little web server. So you can serve up content, maybe even eventually like have a little API that you can publish to control your board. So if you saw in the last few videos I did the Smart Holiday Light project where you can control Christmas lights, and with that I was using the web REPL as kind of an API or a way to control the board. But I wanted to look at using HTTP, which is what most of the modern kind of web applications and things today use to send messages from a web browser, for example, like pressing a button or even just viewing a web page. That protocol, so use that HTTP protocol to build maybe a proper API or way to control a board. And in this video, I just wanted to look at examples that are actually included in MicroPython's source repository. So there's some examples that are ESP8266 specific that show you how to act like a web browser that's downloading a web page, and then also show you how to act like a web server that's publishing a web page that you can access from a web browser on your network. So we'll just kind of dive in. I'll look at the examples here, we'll kind of run them, and I'll show you some modifications you can make to them to make some interesting little changes. So we'll look at how to download data and also how to serve data as a web server here. So let's just kind of dive in. And by the way, I'm going to use this board. This is the Feather Huzzah ESP8266. It's an ESP8266 board. I'll put a link in the description below. This is a good one that we sell at Adafruit, but any ESP8266 board should work for this. And let's go into the main view and we'll see everything. So the hardware is not going to be that interesting. And actually, I have a cat camera right here. So the cat's in the box, although she's not really sure if she wants to stay in the box or not. So I don't know. She's kind of half in, half out. So we'll see what she does. I've also got her favorite little towel back there if she wants to lay on the desk. Anyways, though, so like I said, these HTTP examples are all just inside of the MicroPython source repository. So when this goes up on YouTube, look in the description below. I'll put a link to everything that I mentioned, all the different websites that I'm looking at here. But you can find this on their GitHub repository. And it's inside of the examples and then the network directory right here. And so they're actually a really nice set of little examples that they have that show you how to act like an HTTP client using SSL or secure sockets, which that's pretty cool. It is a feature that the ESP8266 MicroPython port does support, so you can use SSL. There's also a few different HTTP server examples. There's maybe a more complete one and then a simplified one that they have a lot of comments in. And so we'll go through these examples and take a look at them. It is good to know though, like this, this is not a bulletproof web server that you're gonna serve millions of connections or hundreds of thousands of users per second accessing this. This is really just gonna support like one user at a time, because remember, these tiny little boards, there's not much memory here, not a lot of processing power, so it's certainly not going to serve a lot of data. But again, acting as a simple control interface, like publishing an API or a protocol where a web page can send it a request that says, turn on the light or turn on the relay or read this analog input, something like that. That's the kind of simple messaging that you'll probably want to do with a lot of IoT projects. And I think that this is a good starting point for some of that. It doesn't get you all of the way there, and maybe in future videos I might explore this a little bit further. But let's dive in and see how a lot of this stuff works. So the first thing I want to do, so I have my ESP8266 plugged in. I just loaded the latest version of the MicroPython firmware on here. This is from micropython.org. It's the ESP8266 1.8.6 version of MicroPython. So make sure to load the latest version of MicroPython. And if you run into issues, maybe things have changed in the future, go back to that version if this stuff doesn't work potentially. But this is all using kind of a standard socket interface that's in MicroPython. So hopefully this stuff doesn't change too much. And then the first thing I'm going to do is let's connect to the REPL on the board, the serial REPL. So I'm just going to open up the serial terminal for this board. So I'm at the Python prompt. And kind of step one for doing any network related stuff is that you need to get your board onto either your Wi-Fi network or make it look like a Wi-Fi access point that you connect to. That's how you usually use the web REPL. But in this video, I was thinking let's actually have it connect to my wireless access point. And so there are a couple ways that you can do that, and I'll put a link in the documentation for ESP8266 MicroPython. They actually have a really nice little walkthrough here that shows you exactly what you need to do. Uh-oh, the cat is leaving the box here. Oh no! It looks like she might have to reorient herself. Oh no, she's walking in front of me actually. So I don't know what she wants to do. It's actually getting close to dinner time for her, so she's probably gonna whine that she wants to eat. Anyways, though, okay, so now we've got an empty box here, so maybe we'll put the ESP back. Let's see. There we go. My trusty companion has abandoned me here, so we'll zoom in on that. There's not a lot of action that's going to happen with this, though. Like, we're literally just connecting to this thing and watching it do network stuff. Anyways, though, so this is a link to the network info and how to actually connect your ESP8266 to your Wi-Fi network. And so they show you some really simple things, and we'll do this in the web REPL, and then I'll show you can put this into your boot.py so that it just happens automatically, and it actually tells you exactly how to do that in this documentation here. But let's just do what they show. So you want to import the network module, and then you create a station interface by calling the network, and it is the WLAN. So you create an instance of this WLAN class, and you pass in this little kind of constant that says, give me a station interface. This is in contrast to the AP interface. That's an access point interface where your board looks like an access point that you connect to. Like that's usually how like the web REPL works. But in this case, I don't care about that. I actually want the station, or the station interface in this case. So let's put in network.sta sta_if, if I remember correctly. Okay, so now you have the station interface, and then what you want to do is you want to activate it. So they show here, you call active and you pass in true for this. So we'll say staif.active_true, and you might see stuff like this. This is debug output. I'll show you in a second how to get rid of this debug output. It's turned on by default with even this is the release version, which I think they were supposed to turn this off. So maybe it's a bug that it's turned on again. But I'll show you in a moment how to turn this off. It doesn't really hurt anything, although it can confuse tools like AMPI sometimes. So I usually like to turn it off. Okay, so then after you're active, you want to call this connect function and pass in the name of your wireless access point and the password for it. And you're just going to see my access point password here. So, okay, it's not a big deal. staif.connect and Tony-2.4 and then 101 T Decola is my password. So everyone's going to be able to hack my Wi-Fi. Okay, so now at this point, you want to call this isConnected function to see, have you connected to the network yet? Because it takes a little while, you know, it's got to talk to your access point and figure out that it can connect and set the password and all that. It takes less than a second usually, so it should be connected now. And yeah, that returns true. So I am connected, and now my board is on my wireless network, and I can actually see it will have an IP address. So if I call this ifconfig function, this is going to return back a bunch of data. And the very first thing that's returned back is the IP address on my network of the ESP8266 board. So this is useful if this thing's acting as a web server. I can get my IP address so that I can say, hey, okay, access my IP address to, you know, control my thing or whatever. Okay, so that's cool. Let's close out of here and let's put this into the boot.py so that this happens automatically on boot. Now the cool thing is the ESP8266 actually will remember the last access point that it was connected to and automatically reconnect. But it's probably smart to put this code into your boot.py just in case for some reason, you know, maybe the state changes and it doesn't reconnect or whatever. You're explicitly reconnecting in your Python code. Now the easiest way to do this, I'm going to use the AMPI tool, and I'm going to get my boot.py from the board. Now if I just run this, it's going to dump it out. So you can see this is the boot.py. And you can actually see right here where they comment out. This disables the debug output, but it's commented right now. So we'll uncomment that to enable it. But I'm going to get the boot.py and save it as a boot.py file again. And so now if I edit boot.py locally, it's a little easier in a text editor. So first thing I'm going to do is uncomment the top two lines so that I disable the debug output. The next lines, these start the web REPL, but I'm not going to use the web REPL in this example, so I'll just leave those as is. But now let's put in some code here to control or to automatically connect to our access point and actually show you, here's a handy function you can put into your boot.py. So let's do exactly that. They gave us this handy function. We will use it. So we'll put it into here. Now you can code in your username and password here if you want. Or what I was thinking, maybe this makes it a little bit nicer. Since we've got a function, let's make these parameters. So we'll have an SSID parameter and a password parameter. And so I'll put these up at the top as parameters to my function, and I spelled them correctly. And then now I want to call do connect, and let's pass in that Tony-2.4 and 101 tcl as the password for that. So that's cool, that works pretty well. And then let's save that. And now let's ampy put my boot.py. That's going to copy the changed file back onto the board. And then let's open the web REPL. And now what I'm going to do is reset the board. I'm just going to press the reset button on here. And so you see a bunch of stuff, but here's the important thing. So you see here's that connecting to network. That's coming from this function right here. So it's running my connect function. And it connected, and it basically prints out, here's the IP address, and we're good to go. This could not open main.py basically just means that I don't have a main.py, so that's normal. You know, it's not going to run anything at boot. Okay, so we're connected. So now let's close out of the web REPL, and I'm inside the MicroPython source repository right here. So like I said, it's in the examples, cd examples, and then the network directory. This has all of those examples that I was mentioning. So there's the HTTP client.py, this carol.txt, we're going to come back to this. This is part of a Christmas carol, because I was going to show how we'll modify the web server to actually serve this data. And it's, you know, I wanted to get a decent sized file. It's like 7 kilobytes of text, so I pulled some of that out. Anyways, we'll come back to that. So you won't see this carol.txt in the Python source repository. But anyways, the HTTP client, the client SSL, the server, all these examples. So let's look at the code for this. This is just the Atom text editor opened in that same directory. So let's look at, here's HTTP client.py. So as an HTTP client, you're acting like a web browser where, you know, you connect to a website and you request some data. And so the way this thing works is it's actually using just raw socket programming in Python. And you can actually see up here, it imports the micro socket library and it calls it socket. And if that fails, then it just falls back to importing the socket module. Now the reason they have this here is because in MicroPython, your socket library is called microsocket or usocket. And in real Python, it's actually called socket, because there are some differences in behavior there. And so this kind of little block of code right here basically says, okay, try to import the MicroPython version of the socket library. And if that fails, if I get any kind of an exception, it's going to just go and fall back to importing the real desktop Python version. So this kind of means that this code actually can work on desktop Python. And you know what? I haven't tried it, but let's try it on desktop Python. So I'm just going to run python http client.py, and let's see what happens. Oh, maybe it doesn't work on desktop Python. So I just tried it, and it looks like there's a small... well, so actually I was trying Python 2. Let's try Python 3, because that's what MicroPython is based on. And let's see. No, still doesn't work. Okay, well, I'm guessing the intent was that this is meant to run on desktop Python. But as you can see, there are differences between desktop Python and MicroPython. So it's mad about the getSocket adder args, which is probably from the getSocket. Let's see, line 30. What's it mad about here? So that's when it calls main. Oh wait, no, that's so line 15. Oh, the socket connect it's mad about. So it's getting back something that it doesn't expect on desktop Python. So who knows? I have to mess with it more later. But you know, this is MicroPython, so we're going to focus on MicroPython here. But that's what I think this code was trying to do. You don't have to have this code in here. You know, you could just do this and everything's fine on MicroPython. So, and in fact, I'll just save it and we'll try it out like this. Okay, so now let's just kind of walk through. Let's run the code first on our MicroPython board. I'm going to use the ampy run command, which will basically take a script, copy it to the board, run it, get all the output, and then give you back the output and print it out. So we're just going to say run that http client.py, and let's see what happens. So this will take a second. Okay, so it printed some stuff out. So it printed out, here's this address info, here's a connect to that address, and then you get a bunch of stuff coming back here. And I'll unpack this in a second, like what exactly this is. But let's walk through the code and see kind of what it's doing. So the first thing it does is actually defines a function called main, and then it calls that main function. This is just a good general best practice. You know, you could put all of this code into the script, but in a lot of cases, you know, you want to have a nice function where you can just pass in all the state that it needs to manipulate. Usually a convention in a lot of coding that you have a main function, and then we'll call that main function here effectively. The first thing we do is we create a socket. And before I get too far into this, I actually have done a whole video on socket programming. This was on the Raspberry Pi with desktop Python, but I'll put a link in the description below so you can go check this out, and I give a little more background on what sockets are and how to use them on desktop Python. But the cool thing is most of that knowledge transfers over to MicroPython because they've made the APIs be pretty similar. Anyways, though, we'll go back to the code. So you create a socket, and then you call this getAddressInfo or getAddrInfo. This is basically saying for google.com on port 80, what is the IP address of that thing? Because when you use sockets, you know, when we use a web browser, I go to google.com and I don't think anything about what's actually happening behind the scenes. But really, the web doesn't or the internet rather, doesn't understand what google.com is. Like the TCP/IP protocol doesn't have text names for servers. There's this thing called DNS where it's the domain name lookup service. I believe that's what it stands for. But basically, you have something called a domain name, like a easily remembered text name like google.com. And that actually turns into an IP address, which is just a bunch of numbers like this example here. So this 216.58.216.174, that's actually google.com's address. So when I type this into the web browser, it's going and looking up what is the address of google.com and then using that to connect to Google server, because then that uses the whole TCP/IP protocol where, you know, my routers can talk to my internet access provider routers, and then they can go talk to Google's routers, and the entire time they're just using that IP address to say, I need to talk to this server at this address. You know, they're not using google.com as that address, they're using the IP address. So you have to do that yourself when you're not using a web browser. You have to do that lookup and say, I need to know what's the address of google.com. And with MicroPython, because you're using this low-level socket interface, you do that yourself. You don't have a nice wrapper around that. Like I'm sure later on, and there actually are some libraries that people have ported over that make this a little bit easier, but it's good to see kind of the basics here. So that's what's happening right here. And you can see when it prints out that address info, it's just printing out what it gets from the getAddrInfo response. And so that's what we see right here in this top line, this address info. So you can see address info actually returns a bunch of things back. It returns a list with a tuple inside of it, and the first value is 2, and then 1, and then 0, and then an empty thing, and then another tuple that has, this is actually the IP address that it resolved, and then this is the port that it returned back here. So it returns a bunch of data back, and really all that we care about is getting this IP address, and really just this tuple right here of these two values, this tuple right here that has the IP address, comma, the port. And that's what's happening right here. We're basically pulling out, okay, grab the first thing in the list returned by getAddrInfo, because remember, this whole thing is a list. And so grab the first thing, which is the tuple right here, the big tuple, and then grab the last entry. So that -1 says, okay, now index in and get the last entry. That's the nice little Python syntax. So this grabs the last entry inside of there, which is this tuple. So that's the value that comes back, and we store that into this address thing. And then it prints it out. It says, here's your connection address. So you see connect address, and it looks exactly like that tuple above. So that 216.58.216.174 address. So that's the IP address of google.com. So cool. So that's what's happening here. Like we're just looking up that address. And now we connect. And so the connect function needs to take in a tuple that has the IP address and the port that we want to connect to. And so that happens here. Basically, we do that connection. Now it gets a little bit weird in this example. So they have a condition here. If you're using a stream, do this code. If you're not using the stream, do this code. And they explain a little bit in the comments here. Now, it gets that use stream value from the default parameter that's passed in. So use stream is false. So by default, it's actually going to fall back down to this code right here. This is what's running. And now it tells you the MicroPython socket objects support the stream interface directly. But if you're running this on normal Python, you actually have to call this make file function to get a stream interface for things. So it's just another difference between Python and MicroPython. I can imagine the reason they have this optimization is that when you're calling this make file, that actually has to create like a new handle to this. It creates a new object. It's got to allocate some new memory. So if you're doing this in a loop, like you don't really want to do that if you don't have to. So it looks like they've taken a shortcut and just said, you know what, we're going to give the stream interface on the socket itself, which, you know, that's cool. You can do that. And so that's basically saying, you know, this lets you change the code and the behavior here. So let's just try it. Let's change this to true so that now it will do the top code. And I'm assuming that MicroPython, they must support makefile. I haven't actually tried this, so let's see what happens here. So we're going to try this, and we should be running the top code. Now, this should look exactly the same as what we saw. Well, maybe not exactly the same. There is a difference, sorry. So if I look at this code here, the code we were running before, so once it's connected, it does this send that says, okay, send this data out on my socket. And it's actually the same between both of these two little kind of conditionals here. This is just part of that HTTP hypertext transfer protocol. Once you're connected on port 80 to a web server, you send the text that says get, and then you say what you want to get, which is actually everything after the slash on here. Like if I go to google/foo, if I want to do that in my code, I would actually put in /foo, and it's just like in my web browser, whatever I typed in there. There's actually like some encoding that you have to do if you put like spaces in and stuff like that. But that's, you know, if you just want to get the root of a website, the slash is what you want. And then the HTTP protocol version that you're using is what you specify. And usually you probably want to do 1.0. We're up to 2.0 actually nowadays. I think that's the newest spec, which has a completely different interface. It's nothing like this at all. It's more efficient for sure, but not as easy to code against like this. So stick with 1.0 when you're doing raw socket coding. This RN stuff, this is just sending 2 new lines because that's part of the HTTP protocol, that you end your request with a blank line, or basically 2 new line characters. So once the server receives this, it says, oh, they want to get the root. And then it just starts sending back all of the data for google.com, which if I look at in my web browser, I can view my page source. And this is actually all of the data for google.com. There's a little bit more to it, actually, some headers that you don't see here. But this is what the web server dumps back and what this code is going to read. Now, with the code down here, we call this socket.recv, and we pass in 4096. This is telling Python, read up to 4096 characters from the socket and return them just as a string, and then print that out. And so that's what we saw up above here. Sorry, the first time we ran this, this is what we see right here. So this big long thing of almost incomprehensible text is the first 4,000 bytes, or 4 kilobytes effectively, of data returned from accessing google.com. And these are actually headers. So this isn't the content of the web page yet. The protocol for HTTP, it returns these header values, which there's a new header on each line. Well, it starts out by returning kind of a response, which says, okay, we're going to use HTTP 1.0 protocol. Here is your response code, and 200 means everything was fine. Like there was nothing wrong with your request. We're going to service your request and return the data that you want. So that's good. That's what you want to see usually. Now our code doesn't check that, but if you wrote a smarter web client, you might want to check those responses and see what you get back. And then there's also a text response that says okay, that goes along with the 200 response. You might see, like, you know, if I go to google.com/ I don't know, foo. Let's see if that exists. Oh, that was getting the source for it. Here we go. Let's go to google.com/ foo. Boy, I don't want to view source. Come on, Google. Let's delete that. Okay, there we go. So this is saying, hey, 404, that's an error. That 404 is actually the error code that you would get back if you tried to access something that didn't exist on a web server. Instead of a 200, you'd get 404. So that's how your web browser knows that, like, you typed in something wrong or it doesn't exist on that server. So it looks at those error codes. Now everything that follows this is a bunch of these headers, which are, there's a single header per line. So you can see this is a date header that says this is the date that you accessed this web page. There's an expires header. So this is kind of saying like if this thing can be cached when it expires, all kinds of stuff here. Now the headers end with a blank line, just like the way we ended the request with a blank line. So after we see a blank line, then we'll start to get back the web page data in here. Now the difference between these two requests, or the way that these two bits of code work, you know, in this bottom code that we first ran, we only get the first 4,000 bytes and then we print them out. So, you know, we're only seeing just a little bit of the headers because there's a lot of headers, so we're not even getting to the body yet. Whereas this one, we're calling this socket.read function, and that actually will read all of the data until the server stops sending it or closes the connection, basically. And then it will put it into memory and then return it back to you and try to print it out. Now here's the problem. If you noticed, when I ran that code, I got this error, this, you know, memory allocation failed, allocating 26,000 bytes, almost like 26 kilobytes effectively, which makes sense because the ESP, it only has 96 kilobytes of memory, and MicroPython takes some of that. So, you know, that's getting that much memory can be difficult. But what happened was it tried to read all of the data from the server into memory and then print it all out. And it couldn't do that because it couldn't allocate enough memory to store it. So that's a problem. You know, how do you deal with, I want to print out a big web page or something here? Luckily, it's pretty easy to work around this. So the read function can also take in a number here. So this can say only read up to 4096 characters. So, you know, I can do that, and let's save this and let's run this again. And now we should get exactly the same response as we saw before. Oh, well, actually we get a slightly different response. That's interesting that it looks like we got more data back this time. So maybe we weren't really getting 4096 bytes. This does look a little short for 4K of data. So interesting that there's a difference there. But you can see that, you know, it cut off somewhere in the middle of this obfuscated JavaScript. So we certainly didn't get the entire web page here. But that's one option. If you know that you only have a small amount of data, you could just say, okay, only read up to this amount of data, and I'm done. I've got it all in memory. But what we could do is we could actually just do a quick little loop. So like while true, let's get a chunk of data, and let's call s.read, and let's just read like a kilobyte at a time. And then let's print that chunk of data out so that now we don't have to read everything out. Now the one thing is, how do we stop this loop, or how do we know when we're done? And you can actually see the read function, if it'll return an empty or like a blank string if it couldn't read any data. So what we can check is if the length of our chunk that's returned is equal to 0. So if there was no data returned, then break out of the loop. We're done effectively. So just this break command will get us out of this while true loop here. So let's try this out and let's see what happens here when I run this version of HP client. So this is going to take a little bit longer because it's now hopefully reading a kilobyte at a time, all the data, printing it out, and then Ampy is waiting for it to finish, and then it dumps out all the data. And okay, so we just got a bunch of data that's printed out here, so I'm not going to scroll through all of it, but it looks like we got everything because, excuse me, if you look at the bottom, you can see here's the end of the body and the HTML tag. So that's the last thing in a web page. You know, when I go back and view the source of google.com, we'll see the very last thing at the bottom should hopefully be, and boy, there's a lot of stuff for such a simple page, but you know, there's actually a lot behind the scenes at Google on that home page that you don't see. Okay, this, oh wow, oh there we go, there's our body HTML. I thought it didn't have it, but there's our body HTML end. So we got the whole web page, so cool. So I just wanted to kind of show in this example, you know, this is low-level socket programming. You're accessing a web page and downloading all the data. So just a nice little smart thing that you probably want to do is logic like this, where you read things a chunk at a time, because in most cases, a web page, you're not going to be able to read all of it into memory, especially on these little boards. So grab a chunk. In this case, I'm printing that chunk out, but you know, maybe I'm like searching for a certain response or something. You know, I could put that logic here instead of printing it out. You know, it does get a little tricky when you're trying to find something in a web page. Because if you have to break it into reading it over chunks, then your searching logic needs to work across those chunks and things. So it gets a little complex. So, be careful. I mean, if possible, if you know your web server only returns a small amount of data, then just call, a read that can read up to that amount of data and be done with it. Don't worry about trying to do all this chunking logic for this. Okay, so that's the client example. Now there is a client SSL example. I haven't tried this one yet, so let's try it. Let's see what happens. So let's do ampy run client or HTTP client SSL.py, and let's see what happens. Hopefully this works. Now, okay, hey, this looks like it did something. So it returned back some Google.com data. This looks like the first 4K of it. So let's see what's different about this one. So it looks pretty similar at the top. They're doing that socket stuff. That's really interesting that they import this underscore socket module. I've never heard of that module. I don't know what that's doing. Maybe this is an internal socket thing that they're using. Not exactly sure what's going on with that. This is importing the micro SSL module, which I would assume is modeled after the SSL module in Python. Everything looks pretty similar at the start, although notice instead of port 80, we're using port 443 because that's the port that SSL connections typically use. But we're still getting the IP address and stuff as normal. But now we're calling this, we're calling connect, so that's going to initiate the connection to google.com on port 443. And then we call this ssl.wrapped socket. So we create an SSL wrapped socket. This is a Python thing. You can find this in the SSL module documentation in Python, where once you connect with a socket, you can wrap it so that Python, its SSL module, will take care of this really complex process that SSL uses to encrypt your connection. So it does like this handshake, and it looks like the keys that the server has, and does all this validation and stuff. The nice thing is, like, this one line of code is doing all of that for us, so that's pretty cool. Okay, it looks like it prints out the SSL wrapped socket when it starts. That's interesting. Let's see what it printed out. So, okay, so this is where it printed out that SSL socket. Not very interesting, but hey, at least it's not a null object, so it worked, obviously. And then the code is basically the same, it looks like, right? So we're calling socket.write. We're asking for the root of the web page again, and then we're reading the first 4K of it. So I could change this and add that loop in here if I wanted and print everything out, but that's pretty cool. So it does look like SSL works. You're going to want to use that SSL wrap socket, and then it looks like it's pretty straightforward. And you could probably look at the SSL module documentation in Python to see, get some hints as to what you can do. But I mean, realize not everything might be supported in MicroPython. And there is actually also the documentation for this. If I go back to the MicroPython libraries, the Python standard ones, yeah, here's the micro SSL module. So, okay, so all you have is wrap socket in here. So yeah, don't expect to do a lot much beyond that. So when it does warn you, it doesn't validate server certificates. So, it's like people could man in the middle and, you think you're accessing google.com, but it's actually someone else accessing it. So be careful. It's not totally secure. I wouldn't put like my critical life-saving information, inside of here. That's, something that people could get. Okay, so the client stuff looks great so far. Let's dive into some of the server examples in here. So there's the HTTP server.py, and then there's the HTTP simplistic.py. Let's see, and there's actually a commented version and an uncommented version of the simplistic socket server. So let's look at the commented version. This is kind of cool. This is nice that they provide this. So let's see let's see what we need to do to run this. So when I ran this before, it's going to act as a web server, and basically you're going to access it from your web browser, and it'll print out how many times it's been accessed. So it keeps a counter, and then it just prints out, it says, hello, here's the count of times that you've accessed this. Okay, so what I'm going to do is let's do ampy run -n HTTP server simplistic commented.py. Okay, so that's running it. Now I don't see the output because I gave the -n option that says just run and return. Don't wait for the output from this because this has a main loop inside of here, so it's never going to return. Now it's if everything's working, it should be waiting for connections from users. Now I'm going to connect to the serial REPL just so we can see the output of this as we access this. Okay, so now I need the IP address of my MicroPython board, which actually I forget what it is, but I have it in the scroll back here. Oh, I thought I had it in the scroll back, but I might not, since I've got all of google.com inside of here. So, oh, I do. No, stop. Go back. Oh boy, now I've really made a mess of everything here. Wow, this is, I scrolled up a little too far. Okay, here I think we're close to getting the IP address. Almost. It's not in there. All right, here, we'll do this the easy way then. Let's take our server, let's make this the main.py so that it runs when it boots up. So let's do ampy put HTTP server simplistic commented, and we'll put this as main.py. So now this will run when the board reboots. And now I'm going to connect to the serial REPL, and I'm going to reboot the board, and now we'll see it just connected. So, you know, we see my boot.py connection logic. Here's my IP address of my MicroPython board, and now it's actually saying, hey, I'm listening, connect your browser to this host. I think they have a bug in their code here. But if I use this IP address and port 8080, let's see what happens. So if I go to HTTP and then port 8080, then hey, check this out, hello number 0 from MicroPython. And if I access this again, hello number 2. You might be wondering, like, where did number 1 go? And that's actually because your web browser sometimes will send a request that you don't see to the server because it's actually trying to see, is there a little icon for this web page, this little favorite icon. So that was request number 1, which we didn't actually see. You know, we didn't initiate it, but our web browser did behind the scenes. So you see that sometimes. Okay, so if I look back here, this is kind of cool though. It's actually printing out, this is the serial REPL. So you can see it's every time it gets a connection, it's showing me, okay, some client has connected, and then here's the request that the client sent. So these are kind of the headers for that request. And then it's, let's see, well, let's go to the code and let's kind of walk through it and see what's happening. But this is cool. So this is a little web server. It's not showing the most interesting stuff, but it is a server here. So let's see how this thing works. So again, same convention. It looks like, you know, they're trying to make this work on desktop and MicroPython, but I wouldn't be surprised if there's still some small differences. This content is basically where they're defining this is the web page. Now, this is actually more than just the web page. This is showing, this is the HTTP response that's coming back. So, you know, the first line in here is, here's your HTTP 1.0 200 OK. Like we saw when we accessed google.com, it responded back with the same thing. So that says, everything's good. Here's your web page. Here's your data. There's a blank line which says, okay, we're done with all the headers and the response data. Now here's where the response data starts effectively. So that's what this is doing. Now this little thing is a Python string formatting thing because this is where it's going to insert in, okay, how many number of times has this been accessed? And then again, it looks like we're defining a main function here and we're calling it at the start. So that's all normal and what we've seen before. We make a socket again. So this is actually almost no different than when you're acting as a web client. It's just some slightly different ways that you use sockets. Okay, now we're basically getting the address info for the 0.0.0.0 address. This is kind of how the socket APIs work. This is saying listen on any interface. So this will listen on both the IP address of my board that's connected to my Wi-Fi network, you know, that has that this IP address right here. So it's going to listen on this IP address, but any other IP address that this board might have, like if it was acting as an access point with the web REPL, it will give its own IP address, a 192.168.4.1 address. So it'll even listen on that interface too, I believe. So this is kind of just saying, just listen. That 0.0.0.0, that just means I want to listen for requests. I'm not connecting to anyone specifically, I'm listening. And then this port is just telling me, here's the port that I'm listening on, port 8080. I could change this, like let's do port 777 and say, okay, let's save that. And then let's put this as, let's reload my script as main.py again. And then let's open up the REPL and let's restart our board. And so, and this text is wrong because I didn't update the script. But now if I go, so if I try 8080, nothing's there because we're not listening on that port. But if I try 777, then there we are. We're back to normal there. So you can change the port that you listen on. And you know, the web protocol typically uses port 80, but sometimes you might want to use a different port. You know, usually I think anything over 1,000 is kind of fair game. Maybe it's even higher than that, but lots of different protocols use different ports. You know, email uses like port 24 if I remember correctly. So don't just go grabbing ports willy-nilly. You need to go and look up and see, is it a used port or an unused port for things. Almost anything above like 5,000 is fair game, and you can use it though. Okay, so then the next thing is we're basically saying, we're calling this set socket options to say, okay, I want to be able to reuse this address. So this is just kind of a thing where if this socket was created on this 0.0.0.0 address ahead of time, there's a period of time where it won't let me grab that socket again. And this is saying, you know what, ignore that. I just want to reuse this socket. So this is like if I ran this script really quickly, it might run into an error that, you know, oh, hey, this socket is already in use. You can't use it, even though the script that was using it like isn't running anymore. So this is basically just saying, just take over that socket, give it to me now, as far as like, I want to use this socket. I don't care what was using it before. You know, I want exclusive control over this thing. And then the next, the important thing is this bind. So this is where we actually say, okay, this socket is going to be associated with this listening address here, this 0.0.0 port 8080. And then listen says, okay, now start listening for connections. And I forget what that 5 is. I think that 5 is the number of concurrent connections that it will accept. If I remember correctly, that's what it is, but let's look it up. Let's look at the Python socket module documentation. So let's look at the 3.5 version of this. So if I look at this, and there should be a listen function in here, and let's see what this thing takes. So listen, if backlog, it must be at least 0. The number of unaccepted connections the system will allow before refusing new connections. Okay, so that makes sense. So this is saying allow up to 5 people to try to connect without my code actually accepting one of those connections. But again, you know, remember, you're probably not going to be supporting lots of concurrent users with MicroPython. So, you know, we could put 5 here, but really, I doubt you're going to get much more beyond 1 or 2 on this. Okay, this is where we actually print out this host, which, you know, maybe would have been nice. Maybe you could modify this later to look up the IP address of your board and print it out here. So I guess it's not a bug, but it does seem a little weird that we're not doing that in here. Okay, so now here's where we keep this counter. And then we're in our main loop here. So this is a while true, and it never breaks out of this loop. Unless like an exception happens, it's going to stay in this loop forever. And what it does is it calls this accept function. And accept will wait until someone is trying to connect to your socket. So we're just waiting for a connection. And then once a connection comes in, it actually responds back with the sockets that we can use to send data to that connected user, and then the address info about that connected user. And it actually prints that out here. So if I go back to the output that we saw, or actually here, you can see it here. So here's that client address. So this is showing, you know, something at IP 192.168.1.160, which happens to be my computer right here, this web browser, accessed my MicroPython board. And this port 5,000, 59,000, basically, there are 2 sockets here. There's one socket that's listening on the MicroPython board and waiting for people to connect to it. And then as soon as someone connects, another socket is created internally. It's given a random address, or not necessarily address, but it's given a random port. And so that's what's happening here, is you're seeing this is the socket now that I use to talk to the connected client. So it is important to know that you don't actually respond back to the connected client on that listening socket. You use that listening socket to wait for someone to connect, then you accept that connection, and you get a new socket that is the connection to that connected user. That's where you can send and receive data with that connected user. And so that thing's going to have a different port on here. And so that's what this client S object is. So now when I want to talk to my connected web client, I'm doing it through this client socket and not through this S socket that I used earlier as the listening socket. Okay, so now we just call this recv function. We receive 4 kilobytes of data. Again, you could put a loop in here and do a kilobyte chunk at a time if you wanted. And we just print out that first 4K of data. And so that's what you see right here is the first 4K of all the web data. Let's do that. Let's put the loop in here though. So let's do while true, and let's do chunk equals client socket dot recv. Now I forget exactly how recv signals that it's done, that it has no extra data. So let's look at the Python documentation to see what it looks like. So here's the recv function. Receive data from the socket. The return value is a bytes object representing the data received. The maximum amount of data to be received at once is specified by buff size. It defaults to 0. Okay, so interesting. So I guess it doesn't actually return back how much data it received for this. So interesting. So, I'm not sure if there's an easy way to know that it's done sending data back here then. So I don't know. Let's try something else then, because remember it does give us the file-like interface. So what if I call read instead of recv? Like you saw in the HP client examples, there are 2 differences here. And so if I use this read one, I don't know. I haven't tried this, so let's see if this works. Okay, so we'll call read, and then if the length, if the length of my chunk equals 0, then I want to break out of this loop. Otherwise, I just want to print my chunk of data. And then maybe let's put this request at the top here. And I don't need to grab that 4K of data anymore, but I do want to comment that out. Okay, so let's save that and let's try this code as our main.py. So let's put this back on our board as main.py, and then we'll connect to the REPL. I'm not totally sure this is going to work, but let's just see what happens. Okay, it's listening, so now let's access this, and it's port 8080. I think I put it back on. Okay, so I did that, and I think it's stuck in that loop, unfortunately. So it looks like, yeah, I'm stuck in this loop, or for some reason I'm still reading this data, and it's not coming back. So okay, well that was a valiant effort that I made to see if we could read this in a loop, but it turns out you can't do that. So you probably need a little bit more logic here to figure this out. So obviously you can call recv to receive a chunk of data, but you probably need to see I don't know. I guess you probably need a timeout. I mean, I guess if you are acting as a web server, if a client connects to you and if they send a bunch of stuff and they keep that connection open, you need to decide, like, do I close that connection at some point? Like, at what point do I realize that, like, the client is done effectively? And I guess if you really get down to it, you need to start parsing that HTTP protocol and looking for that new line that says, okay, I'm the client and I'm done sending my request, and then maybe I should finish and move on in that case. So, I guess there are a lot of different ways we could do this. Okay, here's one simple thing that I think might work. Let's try this. Let's do while true. Let's do another loop. Let's receive data. Let's print that request out again, though. So let's do that. Just this little header that says, okay, we're going to start printing our request data. Let's print our request data, and then if our request ends in the value rn, so basically a blank line, then let's break out of this. And then to figure out if the request ends in this, so this is 4 characters, so I want to go from 4 characters back to the end of the string. So this is doing that slicing notation in Python. And I think this gives me byte strings back, so I want to specify that this is a byte string and not a Unicode string, which is what this string syntax would say. So it's Python 3. It's kind of the fun of dealing with that. In theory, I think this will work. I haven't tried this though, so let's see what happens. Let's put this as my main.py. So what's happening here is, if everything works, I should be waiting for the client to send a blank line, and I'll print everything out until I get to that point, and then I'll send my response back. So let's see if that works. Let's connect back to my Repple here. Let's reboot my board so my server starts up. And let's see what happens here. Okay, so we're listening. So now if I access this, is it really listening? Let's see, did I change something here? Let's do, yeah, that's the IP address of this. Okay, let's see what's going wrong here now. Oh, I changed it to port 80 instead of 8080. Interesting. I don't know why I changed to that, but let's do this. Okay, so it did a little bit more, I think. Let's see. You know, I might have gotten things a little bit wrong here. Let's see if I got this correct. Let's have it print out the last 4 characters, and then let's have it print the request, because I might not be going enough characters back. Let's just print out what I'm testing against right here and see if we got what we expected for that. So this should print out the last 4 characters with every chunk that it reads inside of here. Although actually it's only going to get 1 chunk back, so let's go, instead of 4096, let's just go 100 characters at a time. Let's make this a little bit smaller, make it harder for ourselves, because I just want to make sure that this chunking logic is actually working. So let's try this one more time. If this doesn't work, then we'll move on. You know, obviously this is a little bit of experimental stuff. Okay, let's try this. Now we're connected, and I should be able to listen if I access this. Okay, so let's see what happened here. So yeah, my last 4 characters were RN, for that last chunk. So why is that not breaking me out of the loop here? So maybe it is breaking me out and I'm not seeing it. So let's print, you know, let's say received request down here. But it's interesting that this is not evaluating to true, because this should be, and maybe it is, and I just didn't see it break out, but oh, actually it did work, because it just responded back with hello number 0. So yes, okay, it is working. Look, it's responding back, so obviously it must be working. So I was right all along. I fully intended for it to be this long circuitous way to figure this out, but this is ultimately printing out everything that we receive from the client, and it just waits until it gets that blank line at the very end and says, okay, the client's done. Now let's go and send back our response here. And so we're using the send, and we're basically taking that content thing that we defined up here, and we're just dumping it back, but we're giving the counter value, and we're incrementing the counter each time this is accessed for that. And then, oh, it's printing a blank line, I guess, for some reason. Okay, so that's how the simple server works. You know, again, the important thing is it's all just socket stuff, but now we're using that bind and listen to make a special type of socket that's listening for connections, and then you accept a connection, and once you have that accepted connection, you get another socket that you can use as if you were a socket client. You can send data, you can receive data, you can do whatever for it, and then this just happens to implement like a really simple HTTP web server. Okay, so the last thing I wanted to show then is let's modify this server so that it reads a file and prints the file out instead of this canned response, this content thing right here. So, you know, let's just delete that entirely because we're not going to use it. And then, you know, we'll keep this request stuff in here. And then after we received our request, now let's change this logic. So let's have it open a file, read in the contents, and print it out on the client socket. So the first thing I want to do, though, is I need to return back that response. You know, remember that HTTP 1.0 200 OK response. That's what I want to send back as the first thing here. So we'll say, I'm just going to hard code this in, HTTP 1.0 200 OK, and then RN. So this basically says, here's my good response. I don't have any headers with it. Everything that follows after this is the content or the data that I'm returning back. And now, okay, let's open a file, and I'm going to use the context manager so that it closes the file when it's done. So let's open, how about that carol.txt that I'm going to copy to the board in a second. This is part of a Christmas carol, because hey, it's holiday time, so let's we'll open that text, and it's free. It's from Project Gutenberg, so I can use it. And let's open that for reading as my input file. And then inside of here, let's just do a loop. So, you know, this input file is a stream-like object in Python. It has the exact same read function that you saw on the socket before. So I can read a kilobyte of data at a time from the file, like we'll say a chunk, and store it as a chunk here. And then I can just write that out my socket object, my connected client socket. So I'm just going to read a kilobyte, send it out, read a kilobyte, send it out. And I know I'm done when the length of that chunk that I read equals 0. So in that case, I want to break out of the loop. And this counter stuff, I don't need to do that anymore. So that's what I'm doing. This is very similar, as you saw, to reading data from a socket. You know, I'm just doing it from a file. And the cool thing is you get kind of a similar interface here in Python. Like, you can look at them as stream objects in both cases. So they both have this read function. Okay, so let's try this then. Let's save that, and let's put it back on our board as the main.py. And then I also need to copy over that carol.py. So if I look in here, and I'll show you the text for this. You know, it's just the Project Gutenberg, A Christmas Carol in here. And I just grabbed the first 7 kilobytes or so from it, because it's actually like 140 kilobytes, which will not fit into the flash memory on this. So ampy put carol.txt. And it takes it a second because there's a lot of data there to send. And now if I connect to the serial terminal and reset the board, okay, so now let's see what happens. Let's access this, and hey, check this out. Oh, uh-oh. Doesn't look like we got all of the data here, so let's see what happened. So I received the request. Oh, this is interesting. Okay, wait, let's try this one more time. Let's see what happens if I access this. Oh, wow. Boy, something's mad. Something's in an infinite loop here. Uh-oh. Wow, I thought this example would work a little better than I intended here. Okay, let's cancel out of that loop, and let's go back to our code here. So let's delete all this request printing stuff, because, you know, I'm not even paying attention to the request. I'm just going to blast out this 200 response and then all of my data here. So let's just ignore printing things out. And then maybe it was getting caught somewhere in here where it was just not receiving the end of this that it expected. But anyways, let's go back and let's recopy our web server to the board. Yeah, we'll do that. But it is good. It did read a little bit from the file and print it out, so that works. I did this ahead of time and it did work, but you know, maybe I might be running into an error that I didn't make the first time I did this. Okay, so let's go back. And okay, so we're getting the first kilobyte, but we're not getting the rest of it. That is interesting that we're only getting a little bit of the data here. We're getting, you know, that first K. Let's increase this and make sure that we get more data, that we see that what I think is happening, that it's, you know, it's just reading that first chunk and then it's not seeming to get the rest of the data in here. So let's open this up. We'll reset our board. And now when I access this, let's see. Oh wow, it's even slower now. Let's see. It might have done something. Wow, it's not even responding to this. So interesting that this is not working. This was working right before I tried this, but for some reason that it's not reading this file, or at least it's not dealing with responding with it as well as it was before. So I don't know. Interesting thing. Oh boy, here we go. It looks like it just received a couple requests, and okay, there we go. We're getting more data this time. So okay, it just took a long time to respond there. That's a little weird why it took so long to respond. Again, you know, little boards, experimental code, so don't expect everything to be perfect. But it is fascinating to me that we're not getting all of the data read back from this file. You know, I'm asking to get a kilobyte chunk. And it's giving me the first kilobyte chunk, but it looks like we're not going through and getting the rest of the data there. So something to experiment with more in the future. You know, this kind of a thing should work. but I'm not sure why it's working not working in this case anymore. So something to look at later for this. So anyways, though, I'm going to wrap this up. This is about an hour long, so I don't want to go too much longer. I will just real briefly look at, there is another HTTP server example. This one is a little more advanced. So this is actually the one that I used before, so maybe this was the difference here, that it was, doing slightly different code. So it's, this one has a concept of using that makefile function to get a stream-like interface in here, and then you can actually call like the readline function on it. So check out the HTTP server example. It's a little more advanced, doesn't have as many comments, but this is maybe closer to the real way that you'd want to implement a server in MicroPython. And then there's also an SSL version, which is really cool. And I tried this out earlier, and it does work. You can make a server that uses SSL. Now the big caveat is it doesn't have all of the certificates that your web browser expects a real SSL server to have, because that's many kilobytes of certificates. Like, you need certificates that say, these top level registrars, there are only so many of these top level certificates. They sign all the lower level SSL certificates, and that's how this whole chain of trust works. That, I say I'm google.com, I go to this registrar, I prove it, I show them like my business license and all these details and things that show that I really am Google, and they sign my certificate and say, I am VeriSign, or whoever these top level signers are, and Google cert is from Google. We say that it's true. And so when you access an SSL server, your client asks for all of those certificates. It's, give me your papers, basically. It says, tell me who you are. And it does all of this crypto to verify that the certs that it gets back have been signed correctly, and that they match certain like top level certificates, that, the VeriSign cert that your client knows about matches the one that this server gave me back in that case. And that's how it can know, like, oh, if someone tries to insert themselves in the middle and claim that they're google.com, they're not going to be able to sign a cert using VeriSign's SSL certificates. So, they're not going to be able to look like that same cert. And your browser will instantly know. And that's why you get some of these warnings up here that say, oh, something's wrong, like this big red X. So long story short, you don't have those certs. You don't have an SSL cert on your board that your web browser will recognize. So when you use this example, you get a lot of warnings from your web browser. Like, Chrome won't even let you access the web page. You have to click through a bunch of hidden buttons that say, I'm advanced, I trust this malicious server, I really want it to steal my data, yes, accept that. And if you click through all of that, it will finally let you get through to the web server and show you the data. But just realize, this is not like a user-friendly experience for this. It's, maybe just more of a proof of concept that you could do SSL stuff, but there's a lot more work to make it feel like, something that your phone or a tablet would access and everything would work. It's a little more complicated right now. So, okay, I think this is it. I'll wrap it up. I don't see any questions. If folks have questions, throw them in the chat. But anyways, this was basically just a quick stream. I wanted to look at examples of the network access with ESP8266 MicroPython, and specifically the HTTP or Hypertext Transfer Protocol examples. So we looked at examples of how to be a client, like a web browser that downloads data from a website, and then how to be a server, like Google.com or Adafruit.com, that exposes data that a web browser can access. And you can do both those things with ESP8266 MicroPython using the socket interface that it has. So you can look at these examples. These are included in MicroPython source code. I don't think the documentation really mentions them much, and so that's why I wanted to highlight in this video these cool examples that you might not even know are there, but go check them out. And like I said, there are a bunch of links I'll put in the description when this goes up on YouTube, so you can find this code. You can find some of the web pages I looked at, and like some of the videos I mentioned. I did a video on socket programming in Python that might be a good kind of overview to help you understand some of it with MicroPython. So until next time, thanks a lot for watching. So check out youtube.com/Adafruit. That's where this video will go up, and all kinds of other fun project videos. Check out twitch.tv/Adafruit. That's where I stream things live. I like to do a stream on, excuse me, on Tuesdays and Fridays. The next couple weeks are kind of holiday coming up, so I think I'll probably have a couple streams at least one stream next week, but probably not in 2 weeks or so. So we'll have some holiday break. But look forward to some more fun MicroPython stuff. Until next time, it's Tony from Adafruit. So thanks a lot for watching. See you later.